This question says that with respect to the region O, the points A, B, and C have position vectors given by this, and this. The line L passes through B and C. Find the vector equation for line L. Let's quickly do that. So for part A, to find the vector equation, I want this right. Give me a second. Okay. So we write R equals, write down the vector A, 1, 2, 0, plus lambda. Oh no, sorry, they were asking from B to C. So we have to use the coordinate of B. So if I start with the coordinate of B, that's going to be 1, 3, minus 2, plus lambda. And now I have to do C minus B. So 2 minus 1, 3, minus 1, minus 3, and minus 2 will be plus 2, which gives me R equals 1, 3, minus 2 plus lambda. This would be 1, this would be negative 4, and then a 5. Now we must write it back in ijk form. So I plus 3j minus 2k plus lambda bracket 1 I, what is I, minus 4j plus 5k. That is part A. Part B says find the point P is the foot of perpendicular from A to L. Find the position vector of P. All right. So let's start part B from here. Okay. So the point P is the foot of perpendicular from A to L. So we have the coordinate of A, which is 1, 2, 0. And then we have the vector line, which is the line L, which is R equals, I'm writing it in column vector form, 1, 3, minus 2, plus lambda, 1, minus 4, 5. And we have to find the coordinate of foot of perpendicular from the point to the line. So we'll have a P somewhere over here. Okay, so the first step is you write down the position vector for A, that is 1, 2, 0. Then you write down the position vector for the foot of perpendicular, which is OP in this case, and that is always equals to this, the line on which it lies on, which would be 1 plus lambda, 3 minus 4 lambda, and minus 2 plus 5 lambda. Okay. Now we have to find the vector AP. So AP would be, you can find AP or even PO, it's the, sorry, PA, it's the same thing. So this would be OP minus OA. So OP is 1 plus lambda minus 1, and then 3 minus 4 lambda minus 2, and then minus 2 plus 5 lambda minus 0, which gives us a lambda, 1 minus 4 lambda, and minus 2 plus 5 lambda. Okay. The next thing you do is equate the dot product between this vector AP and this vector 1 minus 4, 5, and equate it to 0 because these two lines are perpendicular, so their dot product must be equals to 0. So dot product of AP and 1 minus 4, 5 should be equals to 0. So AP is lambda 1 minus 4 lambda minus 2 plus 5 lambda dot 1 minus 4, 5 equals to 0, which gives lambda minus 4 plus 4 lambda, sorry, plus 16 lambda. Minus 10 plus 25 lambda. And this is equals to 0. Okay, now when you solve this, you'll get lambda equals 1/3. And we need to find the position vector of P. So what we'll do now, we'll just substitute the value of lambda in this equation, and I'll tell you what you'll get. You'll get 4/3, 5/3, -1/3. And now when you write it in IJK form, you get OP equals 4/3I plus 5/3J minus 1/3K. That's part B. Part C is the point D is a reflection of A in line L. Find the position vector of D. All right, so for part C, we already have a point A, which is 1, 2, 0. And we already have of the foot of perpendicular, the coordinates of that, which came out to be 4/3, comma 5/3, comma -1/3. And they want the point of reflection. Let's call this F, the foot of perpendicular. And they want this, the reflection of A along the line. And we will call this X, comma Y, comma Z. So now we use midpoint formula. We know 1 plus X over 2 should be equals to 4/3. Then we know 2 plus Y over 2 should be equals to 5/3. And 0 plus Z over 2 should be equals to -1/3. Solve all of these, you'll get X equals 5/3, Y equals 4/3, and Z equals -2/3. And in the end, we write it in IJK form. So we write OD equals 5/3I plus 4/3J minus 2/3K. And we are done.